so we're going to be working in now our last section, or last chapter, which would be chapter 12, which is sequences series. And we're going to start with 12.1, which is sequences and summation notation. So a sequence is a function whose domain is a set of natural numbers in terms of the sequence. So basically, you're going to have a value for 1, a value for 2, a value for 3, a value for n onward, right? So you still have an infinite number, but we're only going to be hitting with the sequence. So we have the first one, the second one, the third one, the fourth one. It's just, and this is actually a little bit more natural for humans of how we operate and you deal with life. You're not really used to dealing with continuous stuff. Like, well, I guess you are. Like, time's continuous, right? You can split that up as much as you want. But when you're dealing with things, you have an events, you put them in sequence, right? So you usually write an as a function. So instead of writing function of f of n, we just use a1, a2, a3, a4, and so forth, right? This is called the first term, second term, and this is called the general term, or the nth term, right? So I'm going to do a couple of these. I'll have you guys do a couple, so I'm not doing them all. And this one really, out of all the classes I've taught, this introduction to series would be the easiest and the best thing to do over chat, because then you just think about it and produce a number, just like no pencil writing. Really. All right, so let's do the first 5 terms. So here, if this is my general sequence, my first 5 terms is here. The first one would be a1. Well, a1 equals to what? Well, it'd be 2 times 1, which is 2 minus 1, so it'd be 1. The next one would be a2, which is 2 times 2 minus 1 would be 3. And we usually don't write a1, a2, a3. We usually just put 1, 3, 5, 7, 9. And then the 100th term in this one, the 100th term here would be 100 times 2, so 200 minus 1, so it'll be 199. So that's the 100th. And onward. So do me a favor in chat, write the first, for C here, write the first 5 and put a little dot and then do the 100th, right? Just crunch that out real quick for me. Is it the same? It gets close. So the first, you guys are, yeah, that's right. Okay. So, yep. So the next, so here, if we take 0 here, all right, so n squared, so 1 squared is 1, minus 1 is 0. 2 squared is 2, minus 1 is 3. 2 squared is 4, minus 1 is 3. I have all the numbers in my head, just not spin them out the right way. 4 squared is 16, minus 1 is 15, and then, yeah, you guys have the rest here. It'd be 15, and then 24, and then, that's the first 5. No, that's the first 1, 2, 3. I forgot 8. Hi! 9 squared minus 1, 8, 24, and then here, 100 times 100 would be 10,000. 10,000 minus 1 would be 999. Okay? All right. Yeah, I missed it. Sorry, Ruby. All right, let me do this one, and then I'll have you guys do this one. So we have n over n plus 1. And so here, for the first term, would be 1 over 2. The second one would be 2 over 3. The next one would be 3 over 4. The next one would be 4 over 5. The next one would be 5 over 6. We get all the way to the 100th term. It would be 100 over 101. Oops, 101. Okay, so go ahead and attempt this one real quick. See how that one works out. And for the 100th term, just leave 2 to the 100th power. I don't think we want to crunch through that. Sorry. You can still see it. There you go. So Wolfram Alpha. Let's just crunch out what that awful number is. Yeah, that's what I want. Yo-ho, here's your number. Don't type that in chat. All right, so yeah, you guys got the up to that one, then yeah. Okay, so you guys are getting it. All right, so that's the one thing I wanted you to, to actually experience for yourself. So here, our first one, so we'll have -1/2 because here if I plug 1 into 1 to the, let me just talk about 1 to the n power real quick. So if n is even, so hold on, this implies that if n is odd, we get 1. If n is even, we get, or no, if n is odd, we get -1. If n is even, we get 1, right? And so this is just a way for the sign to flip. And if you wanted the other way around, you just put +1 or -1. That either works, right? And so this is just a way of constantly flipping your sign. This -1 over n is just a way to flip your sign. So here, so it's just going to be 1 over 2 to the n, so this will be a fourth, and then you're just going to constantly flip signs. And so here, 1 over an eighth, and that'll be negative. The next one will be positive. It'd be 1 over 16, and then 1 over 32, and that would be negative, and then 100, so that's even, and so that's going to be positive, +1, make that positive, make that +1, that's even, so be 1 over 2 to the 100th power, which is this ghastly thing, right? All right. So here, so you can do the same thing in reverse, and you're going to do this on your homework as well. Is if, so here, I'll do one and you guys do one. Which one do you guys want to do, A or B? No votes? B. You guys want to do B? B. All right, most people want to do B. All right, so I'll do A. So here, if I want to find out what the general term of all this is, so how would I approach this? So I would, if you see a fraction, usually I split the fraction into the sequence 1, 3, 5, 7, and then the other sequence of 2, 4, 6, 8. So that's usually what I do for a fraction is I split them up into the upper and lower sequences and figure out what to do from there. From here, I can see, so we're going to say an is equal to something, and it's going to be something over something because it's always a fraction, right? So here I'm doing, here these are my odd numbers, and here are my even numbers, right? And so my first number here is 1. My second number here is 3. And so if I wanted to produce that, it'd be, I'd have 2n minus 1, right? Because here I go up 2 every time, right? But if I start at 2, I'm 1 too high, right? That makes this, that'd be down here because the bottom's 2n, right? This is just 1 times 2, 2 times 2, 3 times 2, 4 times 2. So that's just 2n, right? I can kind of put together the sequence. This is just 2 times whatever my number is. For the odd one, I'm still, my difference here, right? The difference between these two is 2. The difference between these two is 2, right? The difference between these two is 2, right? So I still want to do 2n each time. I just, in order to get the correct starting number, I just need to minus out a 1. So that's kind of how I crunch through that. So what's, in general, what's the an for this down here? Yeah, so you guys are doing -2 to the n power, right? Which is correct, right? So here, if I have 1, I have 1. If I have 2, this becomes 2, -2, so this is correct. I guess this is 100% correct. I promise you that almost every book will write it this way, which is massively less compact as you guys written it. And this is what I was going to write, but this is more correct in some respect. It's just that if I see switching signs, I just automatically just slap that in, right? I just slap it in, right? And then I figure out what's the actual magnitudes of the numbers doing. So that's either works. I mean, you can directly go for it, or here, if you see switching signs, just slap that on and then do what you need to do from there. All right. Okay, so we've gotten kind of used to sequences and series, or sequences right now. We've gone from a general formula to finding things. We've gone from a sequence to doing these things. So that's really good. All right, so let's do some recursive defined sequences. We'll talk about partial sums and then we'll go from there. All right, so recursively defined sequences. All right. I did think I updated this morning and didn't update yours, guys. Yours probably says fn1, fn2. It should say fn minus 1, fn minus 2, if I'm not mistaken. I don't know if I re-uploaded the notes. I don't think I did. So it's just a minor correction for you guys there. So recursive means the end sequence may depend on some or all of the terms preceding since the sequence defined this way is called a recursive sequence. So let me explain what this means. So here we're going to find the first 5 terms of a recursive sequence, just to get used to this. All right, so I'm going to have my little sequence here. So I'm going to have 1. For A2, I'm going to take it, it's going to be 3 times n minus 1. So n minus 1 in this case would be A1, right? Plus 2. Well, that's equal to 3 times 1 plus 2, which is 3 times 3, which is equal to 9. So my next sequence here is 9. A3 is going to be equal to 3 times A2, right? So 3, 1 less than that would be A2, plus 2. So what we have here, we have 3 times A2, which is 9, plus 2, so we have 11. So this is equal to 33. All right, so do me a favor, find A4, and I'll give you A5. So try to find A4 real quick. You didn't. Oh, sorry about that, guys. I guess I thought it was such a minor typo. We didn't even worry about it. Um, Almost. You forgot to add the 2. Okay. So it'd be 3 times A3. Yeah. Well, 1 if I was correct. So plus 2. So we have 3 times 33 plus 2, which should give you, this become 35. 35 times 3 would be 105. So, 105. And then the last one here would be 321, would be 3 times 107, right? 3 times 107 would give you this. All right, so that's a recursive one. So this is one where it only depends on 2. Here's a famous one. Let's do it and then see if anyone can name what it is. And so let's just go through the terms. And so here I'm actually not going to show you the formula. I'm just going to crunch through it. So it'll be 1 and 1. So my first 2 are 1. And then the next A3 would be the first one, or F3 was the first one we can do here. It'd be F2 plus F. Let me actually write down. F3 is equal to F2 plus F1. So this is 1 plus 1, which equals to 2. F2, or F4 is equal to F3 plus F2, which is equal to 2 plus 1, which is equal to 3. And then here I'm just going to filter it in. So these 2 added up would be 5. These 2 added up would be 8. These 2 added up would be 13. These 2 added up is 21. These 2 added up is, if I can do math in my head, 34. These 2 added up would be 55, and so forth. The Fibonacci thing. Yeah, this is the Fibonacci numbers, right? So the Fibonacci sequence, which appears like everywhere. And so that's actually a recursive relationship. It's like, well, that's fun. Isn't it fun math? And then here you just type in fib and not fibbage. Fib 120. Fib fun. Fidget average numbers. There we go. And watch like a whole bunch of fun things on it. The math is fun. Let's just look at Wikipedia for a hot second. And so if you do this, you ended up with a golden spiral, creates things for ratios, and how this appears like everywhere in nature. And you can use this to, we'll be doing this, the shadows, and it just ends up popping up more places than you could guess, really. And so it's just something interesting. All right, let's talk about partial sums. I knew it. All right. So given a sequence, A1, A2, A3, all the way up to AN, the partial sum, so we call these partial sums, where if I add up just where the sum of just the first one is just A1. If I add up the first 2, that's S2, right? If I add up the first 3, that's S3. If I add up the first 4, that's S4. If I add up the first 5, or first n of them, I guess I'm on 10 now, and is Sn. And notice that this itself produces its own sequence, right? So if I take a sequence, this partial sum becomes a sequence, right? And then I could take the partial sum of the partial sum, and that itself is a sequence, and add infinitum, right? And so this is this, we call this the nth term. So this is just what it means to be a partial sum. So let's actually just crunch through one real quick, or 2. And then I almost never use the partial sum. I almost always use this, the sigma notation. Just what you use out after this class. So find the first 4 partial sum and the nth partial sum of the sequence given by this. And so here we have 2 of them. So let's find out what these partial sums are. All right. And so the reason we find the first four before we find the n partial sum is because the first four gives us a hint of how to find the n partial sum from the tricks we've learned already. So let's do this. So S1. S1 is equal to A1, right? Well, what's A1? A1 is just 1 over 2, right? So this is just a half, right? Well, S2 is equal to S1 plus A2, right? Because here, if I just add up, or so it's equal to A1 plus A2 or S1. S1 equals to A1, right? And the reason I'm writing it this way, because here I'll have a half plus a fourth gives me 3/4, right? If I convert this over. Now, if I do S3, notice I can write A1 plus A2 plus A3, or I could just write S2, which I already know is 3/4, right? Plus A3. And so this would be, this would be 3/4 plus 1/8. And if I did that, that becomes 7/8. And then if I just did S4 real quick, be S3 plus A4. So S3 is 7/8. A2 to the fourth would be 1/16. So 7/8 plus 1/16 gives us 15/16. All right, so now we have the sequence here. We have a half, we have 3/4, we have 7/8, and we have 15/16. So in general, what's Sn? What's the general answer here? Notice here, split it top and bottom. And so here on the bottom, we have this just powers of 2. So this would be 2 to the n, right? So this is 2 to the n. On the top, we have the powers of 2. We're just 1 minus that. We're always 1 less than that. So it'll have 2 to the n minus 1. And it's perfectly fine to leave it here. Another way of writing it is you'll have 1 minus 1 over 2 to the n. And that's just simplifying this, because 2 to the n divided by 2 to the n is just 1. And then minus 1 over 2 to the n is just 1 over 2 to the n. Okay. Let's do this one. All right. So S1 is equal to 1 over, or is equal to A1, right? Which is equal to 1 over 1 minus 1 over 2. And I'm going to leave it this way just so it's easier to see what's going on for a particular reason. So S2 is equal to S1 minus A2. Well, S1 is 1 minus a half. A2 would be 1 over 2. So minus 1 over 2. Oops, this is plus though. Sorry, plus 1 over 2 minus 1 over 3, right? But notice these cancel, so I'm just left with 1 minus 1 over 3. Let's do S3. Here I'll have S2 plus A3. S2 is 1 minus 1 over 3 plus A3, so 1 over 3, so it'll be plus 1 over 3 minus 1 over 4. So these cancel, and I'm left with 1 over 4. Here you can easily guess that s to the fourth will become 1 minus 1 over the fifth. So in general, s to the n, what's my pattern here? I have my pattern is 1 minus 1 over n plus 1. So that's what the pattern is here for that one. Does everyone see how these kind of fall out and fall through? You just crunch the numbers and then you look for patterns. And so here we always have this. If we actually crunch these numbers, we still arrive to the same pattern. Because if I actually crunch through this would have been a half. This would have been 2/3. This would have been 3/4. This would have been 4/5, right? And then the pattern, and then we'd probably write n plus, we'd write n for n, so we'd always have n on top, and then n plus 1. And these should be equivalent. If my brain will fire out and figure out, wow. And these produce. And these are the same. These are the same. I'm not gonna dive into it because I don't want to waste time on it because we still have another section to do. But these produce the same results. Notice that these will produce the exact same results. And to show this would be equal, be a little bit of a step, so we'd have n minus 1, n plus 1. So we'll just move that over. We have 1 minus n over n plus 1 over plus 1 over n, so that'd be, yeah, here I'll just show it real quick. Might as well, as if I'm already there. N plus 1, minus that out, so it'd be plus 1 over n plus 1. If I add this 2 up, I get n plus 1 over n plus 1, which is equal to 1, right? Which is right there, okay? So that's, they may not look the same, but they really are. All right, let's do sigma notation. So this is how it's seen in like 99% of all math, is you'll do it via the sigma notation. And so let me explain what all this means. I guess I should have written it all out. So k equal 1 is your indexing number. So here, but this is how we're indexing it. So it makes sense to have different indexing numbers if you have multiple sigmas, if you're doing multiple sums at once and all this. So this is just whatever your indexing numbers, what counts, 1, 2, 3, 4, 5. This 1 right here is the starting number. So this is where you start. So here I'm going to start at 1, go to 5. Here I'm going to start at 5, go to 10. Here I'm going to start at 3, go to 5. And so this is your ending number. So that's up to what n you go to. And this here is your formula. Okay. So let's go ahead and erase some of all my arrows everywhere. And this one's just easy to explain as we do it. So here if we have k equals 1, so I'm going to add up here 1 plus, so 1 squared is 1. I'm going to add 2 squared plus 3 squared plus 4 squared plus 5 squared, and then I've hit my ending number, so I stop. So this is 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. So if I add that up, this is 1 plus 4 plus 9 plus 16 plus 25. That's 10, that's 20, 10 plus 10 is 30, 30 plus 25, so this is 55. Okay, so let's do B real quick. So here I'm going to start at 3 and I'm going to go to 5. So here I'll have 1 over a third plus 1 over a fourth, because I'm using this as my function here, and my indexing here is j, so 1 over 5. So I've done my 3 terms. That's all I'm doing. So a third plus a fourth plus a fifth. I think I need to go to, what's the shortest one I go to? I think none of these have anything in common, so just multiply them all together. So I get 60. So this would be something 60th, right? So this will be 20/60th. This will be 15/60th, and this will be 12/60th. So I have 47/60th is what that is. Okay, does it make sense what's going on here? And how to do these? You just add them up. Yes. Yeah, okay. So do C for me. Do C for me. Actually, do C and D for me real quick. If it makes sense, go ahead and try it. I'm gonna grab a drink of water super fast. So tell me what you get for C, tell me what you get for D. And then we'll go to the next set of notes. Yeah. Fix my chair. 45 for C. Yes. And 12 for D. Is D just 2? Almost. So let's go through it. Now we got at least some people giving answers. So here we have, so here we're going to just start at 5. So I is 5, so it would be 5, 6, 7, oops, not a comma, plus 8, plus 9, plus 10. Add this up, we'll get 45. Here we're going to go from 1 to 6, and my formula here is 2. So it'll be 2 plus 2 plus 2. So when I is 1, it's 2. When I is 2, it's 2. When I is 3, it's 2. When I is 4, it's 2. When I is 5, it's 2. When I is 6, it's 2. So 2, 2, 2, 2, 2, 2 is 12. Okay? Yeah, okay. So this is just some notation, do this. So now we're going to switch gears from here. So now we've finished all this, we're going to specifically look at sequences that we can add up easily. We call these arithmetic sequences. So let's just dive into that. The other one are geometric ones, but that is tomorrow's notes. Sorry, so let's open up new notes, more notes. Tab notes. Here we go. Open Photoshop. It's only 2 pages. Yay. All right. There's that one. And Photoshop. And this one. Woohoo. All right. Get some layers in here. Swap it out. Trial. Here. Get some more layers in here. Swap it out. Check it out. All right. All right, so let's start with arithmetic sequences. Not what I wanted. Ta-da. Why is this not working? Oh, because I'm hitting the wrong buttons. All right, so here we're going to be doing 12.2. This is arithmetic sequences. So arithmetic sequences always have this form. It's always going to be A, and then A plus D, A plus 2D, A plus 3D, or the nth. The formula always looks like this. It's A to the n is some A, which I think is the book's notation, which drives me a little bit nutty, right? I was like, should we have it different than what the different indexing? But since I'll use these notes next term and everyone has the book, I'm just going to keep with the nutty notation. Plus n minus 1d. So notice here, at the second one, we only had 1d. At the third term, we had 2d, so it's just n minus 1 of that. So A is the first term, which I kind of get why they do it, and D is the common difference. So the D is the common difference of the sequence. Find the nth term. The nth term is given by this. Okay, and so here we're going to just kind of go through, we're going to just kind of mess with it in different ways just to get used to it. So here, if I have A is 2 and D is 3, find the nth term. So the nth term is just 2, we just use the formula, plus n minus 1, 3. Okay, so this is, so if we know the common difference and we know the first term, we can write out any term sequence just for fun. The first term, if we were going to just write out a couple terms, the first term would be 2, the second term would be 5, the next term after that would be 8. What's the next term after that? What's the next term? 13's a little high. 11, yeah, 11. Okay, so notice here I'm just adding 3, adding 3, adding 3. And so if you see, and so here, so given this sequence, 9, 4, -1, 6, 11, because this is usually what you'll see. You'll just see a sequence of numbers. If you want to find out if it's an arithmetic sequence, just figure out what the difference is between each of the numbers. So from here to here, there is a -5 difference. From here to here, it's a -5 difference. From here to here, it's a -5 difference. From here to here, it's a -5 difference. And so D here is probably -5. What's my first term? Well, it's right here, A, or 9. So 9, A equals 9. So I can write out my nth term of my sequence now by saying 9 plus n minus 1 times the -5. Okay, and so notice here, without checking through the formula, if I wanted to figure out what the next term would be, -16, right? The next term would be -21, and just take away 5 each time. Now, if it's given this, do we need to know all this? And so as long as I know it's an arithmetic sequence, I can just take these two, figure out what the difference is, which in this case is, my brain would operate, -6, right? And so here I can find the first 6 terms. So as long as I know it's an arithmetic sequence, I know it's -6. So the first 6 terms would be 13. -6 from 13 is 7. -6 from 7 is 1. -6 from 1 is -5. -6 from -5 would be -11. -6 from -11 is -17. And so notice here we can crunch out the terms, and if I wanted to find the 300th term of this, right, so I just write out my general formula, it would be 13 minus 6 times n minus 1, or n minus 1, hold on, I said minus, did I write it? No, n minus 1. So this is in general, this would be, so the 300th one of this would be 13 minus 6 times 299. And I'm going to crunch that through a calculator. You know, let's not be super lazy, right? But for the same token, I don't want to crunch that. All right, there we go. Wolfram alpha. I need 13 minus 6 times 299. Oops, that is not times. Minus 100, 1781. Perfect. Minus 1781. Okay. All right. So let's tackle something even harder. So let's pretend I know what the 11th term and the 19th term of the sequence is, and I want to find the 100th term. Can you do this? So let me ask you the question. Let me ask the question to the class. Is this possible to do? Not can you do it? Not do you know how to do it, but do you believe it is it possible to do? Yeah, you guys don't seem. Now, why do you believe it's possible? Math. It's math. Anything's possible, right? I wouldn't put it on the paper if I didn't think it was because you put it in the notes. I know someone wrote it. Thank you. Fair enough. Um, so here we have the 19th, and we have anything's possible. Duct tape. So let's figure out what we have here. So we have let's figure out what we have here. So we know that 52 is equal to the 11th A11, right? Which is equal to sum A plus sum n minus 1. Well, we know at n minus 1 here, it's 10 times sum d, right? Here we have 92 is equal to a to the 19th, which is equal to sum a plus 18, n minus 1 of 19 will be 18, sum d. And now all we have to do is tease out what is what, right? And I don't know if you guys have solved. Our 18 d is equal to 52, equal to 92. Have you guys solved simultaneous equations before? Also, as long as you find the answer and get your hopes crushed, it's impossible. Nada. No. So some people have, some people haven't. So in order to do this, you just let's see if I can do this in a way that won't get people confused if you've never seen it before. Solving simultaneous equations is a whole. I teach it. I teach it to my 126 class, and then I reteach it to my 431 class because by that point they've forgotten. All right, so let's kind of tease out how to do this in our head. So if I know 52 is 10 times d plus an a, and I know 92 is 18 times d plus an a, right? So if I took 92 minus 52, I'm left with just 8d, right? Does everyone buy me on that? Because the a's will, if I have a, here, if I took these two numbers, 92 minus 52, which of course is just 40, right? The a's cancel each other out, and I'm just left with 8d. So I know 8d is 40. That's what I know, right? And once I know 8d is 40, I can say d is just 5, right? Because if I took these two numbers and minus them, I'm left with only 8d, right? Because the a's would cancel each other. And 10 of these d's would cancel 18 of those d. Yeah, so you just subtract them. In this case, it's just simple as subtracting. And it's always going to be the case for this. You just subtract the two. So I'm left with 8d. So I'm subtracting the bigger one from the smaller one. So I'm left with 8d, that's d equals 5. Once I know d equals 5, I can just use 52 equals a plus 10 times 5. This implies a is 2, right? You're going to see from there. This is 50, so a must be 2. So here I have my formula of a to the n is now 2. You could have done the same here. 18 times 5 would have given you 90, so leave just the 2. So it's 2 plus n minus 1 of 5. So that's my general formula. What am I asking you to find? The 1,000th term. So it'd be 2 plus 5 times 999. So 5 times 999 would be 4990. No, 4995. 4995 plus 2 would be 4997. Okay. So yeah, so if you ever have the 11th term or the 19th term, I think I give you one just to try out. You just write them out into this form. write out what it's some a plus x amount of d minus the 2. You're going to have x amount of d left equals some number. Then you can solve for d. Once you know what d is, you're just left with a very simple equation, or right here, I guess the simple equation. 52 plus a, or 52 equals a plus 10 times 5. Well, then you can just solve for a and get that. Okay, so that's how you do that. I'll leave this up for 1 second before I swap. I bust out a calculator at the point. Well, if I have 1,000, so if this is 1,000, right? So it'd be 5,000, and then I just take away 5 of it, it'd be 4,995, and then add the 2.